So whenever you have arrays, so you can visit the elements of an array, which we call it as traversing. You can insert a new element into an array. You can delete an element from the array. You can display the elements of an array. So basically you can do lot of operations with respect to array. So the three very important basic operations what you can do is, as I told you, traversing, inserting and deletion. So which we will see all these three operations with the example and with the algorithm. Okay. So what is basically traversing an array? Assume you have an A, which is a collection of elements stored in your computer. So basically A is nothing but an array here. Now I want to print all the elements in an array, or I want to count how many elements are there in the array. So then how do we do this? So we can achieve this by using a concept or a process called as traversing. So when I say traversing, it is basically a process of visiting each element of an array A exactly once. So please remember, you start from the first element and keep on visiting every element in an array till you reach the last element. So you have to visit every element of an array A exactly once, and that process is called as traversing an array. It is also called as visiting an array. So when you visit an element or when you visit an array, the operation or the function could be different. You can print or you can count how many elements. So after visiting the elements of the array, you can do whatever the function you want, or you can do whatever operation you want. Now we will see how exactly this traversing function is implemented. So we will see with the code or what is called as algorithm. And please remember, generally algorithms are language independent. So it will not be confined only to C language or C++ or Java. So when we say an algorithm, it is independent of any programming language, which is defined based on the concept or based on the operation what you perform for that particular job. So here also, we have mentioned the algorithm for traversing the array. One is using the while loop and the other one is using the that is using the for loop. So first we will see using while loop. So these are the steps. So you know, algorithm is a step-by-step procedure for solving a given problem. It will have a finite sequence of unambiguous steps. So when I say unambiguous steps, each step clearly specifies what you're supposed to do. You will not have confusion. Okay, and there should be finite number of steps. So you should know, if I want to implement this or if I want to apply this process, I need to have so many steps. So the first one is you have using while loop. So what is the first step we should do? So whenever we use while loop, so you use some counter, that is initialize the counter. So here k is the counter which is initialized to lower bound. So lower bound is the so from which element you are going to start. So not necessarily always it has to be from 0. So like in the car example, you saw 1965 was your lower bound. Assume you always start from 0. So in this case, k will be 0. Now repeat this step 3 and 4 while as long as k is less than or equal to upper bound. So your k is the counter, so whose range will be between lower bound to upper bound. Lower bound gives you the first element in an array and upper bound gives you the last element in the array. So start from k is equal to lower bound, visit each element, apply the process to a of k. So what is k here? K is first time k will be lower bound. Now when I say apply the process to a of k, it could be printing the element, or if you want to add the elements, it could be anything, or if you want to count, you can keep a counter. So whatever the process you are applying to the element, you can do with respect to the element which is placed in the position a of k. Then after visiting the a of k, now you have to increment the counter. That means you have to go to the next element. How do you go to the next element? You have to increment your index position. So how do you increment your index position? Set k is equal to k plus 1. So please remember, all the elements in the array share the same name, that is a. Only the thing is they differ by their position, that is the k value. And the k value ranges between the lower bound to upper bound. And increase your counter, k is equal to k plus 1. Then again go to step 2, check whether k is less than or equal to upper bound. If the condition is true, again apply the process to a of k. So the step from 2 to 4 is repeated as long as k is less than or equal to upper bound. Once k becomes greater than the upper bound, then come out of the loop. That is the end of the step loop, and come out of the algorithm. So that says that you have visited all the elements in the array, starting from the lower bound position to upper bound position. So this is using the while loop. The same thing you can implement using the for loop. So you know what's the difference between the while loop and the for loop. While loop, you will have like condition separate, initialization separate, increment statement separate. But in for loop, all the three statements will be in one single step. For I is equal to 0, I less than n, I plus plus. Or in this case, for k is equal to lb, k less than or equal to ub, k plus plus. So all the three statements, that is initialization, then condition, then updation, will be in one single line. So that's the advantage of using the for loop. So how to implement that? Repeat for k equals lb to ub. So apply the process to a of k. So this process keeps repeating as long as k is within the upper bound. Once the k value is above the upper bound, you come out of the loop, come out of the algorithm. So that says that you are visiting each element of the array. So, and visiting the each element of an array is called as traversing, or it is called as visiting an element of an array. Now, how exactly it is done, we will take with an example, and we will see how coding can be done. And since in your syllabus, we talk with respect to C language, so whatever the concept we are trying to explain, we will try to explain the programming using C language. So let us see with the simple C program to perform traversing operation, traversing your linear array. So let me take simple example. So include stdio.h, then void main, then int LA. So LA is the name of the array. And in this program, how many elements are there? It is 5 elements. And how do you know it is 5 elements? Since you are initializing the array with 2, 4, 6, 8, 9. So how many values are there on the right hand side of the initialization statement? There are 5 values. So what will be the size of the array? So the size of the array will be 5. So in the first element, you are storing 2, second element 4, 6, 8, and 9. So totally you have 5 elements in an array. Then you have looping variable I, then n is equal to 5. So here, since in this example, n is constant because we have declared using initialization. So here, in this case, the number of elements always remains 5. But you know, the other way you can do is using scanf statement, and using for loop, you can read the elements of an array. So once you say int I n is equal to 5, printf the array elements are, how do you, so here what is the operation I'm doing after visiting the every element of array? Just print the elements, okay? So how do you print? Printf, the array elements are, start from for I is equal to 0, I less than n, I plus plus. First time I will be 0, 0 less than 5, yes, it is true. That means you are visiting the first element. Then come to printf, LA of %d is equal to %d. So LA of 0 equals, what is there in the first position? 2. So LA of 0 is equal to 2. So the first element, the output statement look like this. LA of 0 equals 2. Then I gets incremented. So when I becomes 1, 1 is less than 5, as the condition is true. So you are visiting the second element. So how do you visit the second element, and what is the operation you are doing? You are just printing the element of the second position in the array. So what is that it will print? LA of 1 equals 4. So LA of 1 equals 4. So similarly, you will print I gets incremented to 2, 2 less than 5. So LA of 2 equals 6. Similarly, LA of 3 equals 8, LA of 4 equals 9. Since all the elements are visited exactly once the n value becomes 5. So 5 less than 5, the condition becomes false, you will come out of the loop. So because there are how many elements in an array? 5 elements, and all the elements are visited exactly once, starting from the lower bound to upper bound. What is your lower bound in this example? 0. And what is your upper bound in this example? 4. So you are visiting all the elements in the array exactly once. And this operation, we call it as the traversing. The other two operations which you can do with array is inserting and deleting in an array. Now first we will see what is insertion, and next we will go for the deletion. Now what is inserting? Okay, you would have already created an array. Okay, now you want to insert an additional element into the existing array. So or adding another element to the collection in an array is called as insertion. And whenever you insert a new element into array, so what are the two inputs that is required? One is the element which you want to insert, and the second thing is the position in the array where you want to insert. So two inputs are required while inserting. One is the position, and the second one is the element which you want to insert. So after insertion, now your array gets modified. So in with respect to size, okay, it gets in insertion always the size gets increased. Now, so there'll be rearranging of the existing elements in the array. Now, how it is possible? How do you rearrange the elements? Suppose if you are inserting the element at the end of the existing array, then it is simple. For example, if I would have declared my size as int a of 6, okay. So how many elements space is reserved? 6 elements, the space is reserved. Assume while inputting, you would have entered only 5 elements. So the position will be from 0 to 4, okay. Now the last position, actually there's no elements. So now if you want to insert, already make your pointer point it to the last position and just insert. So in that case, no need to rearrange your existing elements, because already the elements are being placed in the respective position and you are going to place in the last position. So just make your pointer, which is already at the last position, make your pointer to point to the last position in the array and just insert the element. So here there's not much problem. Suppose if you want to insert in the middle of the array, okay. Suppose in the second position I want to insert. Already in the second position some other element is there. Now if you want to insert the element in the second position, now you want to shift from second element to the last element towards the right, so that a space is created at the second position and a new element will be inserted there. So on an average, if you try to insert an element in the middle of the array, on an average, half of the elements must be moved forward, that is towards the right, to the new location, so that a space is created for the new element. And while keeping the inserting the element, please remember, you should not shuffle the order of the elements. You should just shift, okay. Shifting means to the adjacent location. You cannot just jumble, okay. So please keep it in mind. While inserting an element in the middle of an array or in a random position, first you should shift all the elements from the position till the end of the array right, and then you have to create a space for the new element, then you have to insert, so that the order has to be maintained as it is. So that operation we call it as inserting in an array. So let us take one simple example. You will understand how insertion can be done. Assume I have 10 elements, okay. So my size of an array is 10, okay. So where I've stored 1, 2, 3 to 10 in all these positions. Now, so that is my existing array. Now I want to insert a new element, that is 50, okay, in the position 5. Already what is there in the position 5? 5 is already there. But now what is the new element I want to insert in the position 5? 50. So what we do is, from the position onwards, so which position onwards? From the position 5 till the last position, you have to shift right. So when I say shifting right, it cannot be done at a time. First, you have to go to the last element, that is 10, move to the right by 1 position. So 10 will be moved right to the 1 position. Then a space will be created on, they'll be actually moving means just you assign a value. 10 will be retained in the same copy. Now what is that you have to overwrite with that position? 9 should be moved next. So 9 will be moved to which position? 10. Then 8 will be moved to 9. Then 7 will be moved to 8. Then 6 will be moved to 7. Then 5 will be moved to 6th position. So in order to do shifting, you cannot just shift like that, okay. the last person should move to the next position. The previous person should move to the next person. So like this. So you shift half of the elements to the right, so that which is the position you are vacating, that is the fifth position you are vacating, and you will insert the new element, that is 50. So now what you can see, the left hand side element from 1 to 4, it is not changed, and the order from 5 to 10 is not changed. Only the thing is between 4 and 5 you are inserting, which is the new element you are inserting, the element 5. So this type of operation, it is called as insertion. Now coming to algorithm. So how actually it is implemented, or what are the steps you need to follow while doing an insertion into an array or inserting an element into an array. So let us take or let us go through the steps which has been listed here. So algorithm is insert, where we need to have 4 parameters or arguments. The first one is the array, that is A. N is the number of elements in the existing array. K is the integer, that is the position in which a new item has to be inserted. So please remember, K is the position where the new item has to be inserted into an array A, such that what is the constraint? The position has to be within less than or equal to n. Okay. So how do you start with? First, initialize your counter. Set j equals n. Okay. That is, you have to go, what is your j? J is like from where you are shifting. Set your j equals last position, because you have to shift the last element first. So make your j to point to the last position in the existing array. So that is, set the counter j is equal to n. Then repeat the steps 3 and 4 while you can shift as long as j is greater than the k. So k is the position where you want to insert. So you have to shift all the elements towards the right side of the k. So that means your j value should be greater than or equal to k. Then keep on shifting to the right. So what is the condition you have to check? You have to shift all the elements towards the right such a way that the elements which you are going to shift, their positions should be greater than or equal to k. Then if j is greater than or equal to, say, first time, what will be your j value? N value, that is your last position. In the previous example, what will be your j position? 9, because first position will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So your j will be 9. So and 9 is greater than or equal to, the position is 5 means 9 is greater than 5. Yes, it is true. So then move the jth element downward. Moving means what? You have to assign the value which is stored in j to j plus 1 position. So how do you say? Set a of j. So what is there in a of j? 10 is there. Move it to a of j plus 1. That is in the next position. So a of j will be moved to a of j plus 1. So 10 will be moved to the next position. Again, after moving, now your j value should be decremented. So one shifting is over. Now decrement your j. So now j becomes 8. Again check, again go to the step 2. So 8 is greater than or equal to 5, as the condition is true. Again come to the third step. Now in the previous example, now 9 should be moved next. So that is, a of 8 should be moved to which position? A of 9. So the 9 will be shifted into the 10th place. So that is how you do. So again j gets incremented. Now j becomes 7. So this process keeps on repeating till you move 5, that is the fifth element, that is on the fourth position, 0, 1, 2, 3, 4. 4 is moved to the next position, that is the fourth element is moved to the fifth element, that is 5 is moved to 6. Now this gets vacated. Now what is that you do? Once j becomes 5, the condition becomes false. So once j becomes 5, 5 is greater than or equal to 4 becomes false. You will come out of the loop. Then insert a of k. So insert a of position 5 means in index position, what it will be there? 4. Please remember, while mentioning, we say position 5. We don't say position 0. Okay, the first element in an array will be in the first position, the second element will be in the second position, third position, fourth position, fifth position. If you are saying position 5 means what will be your index position? 4, because your array starts from where? 0, 1, 2, 3, 4. So that is the reason. So insert element set A of 4 equals item. So now what is that you are going to place? A of 5 will be placed in, sorry, A of 4. So in the fourth position, that is in the fifth position, you are going to place the element 50. What is your item here? Item is 50. Then after inserting, now earlier how many elements was there in an array? 10 elements were there. Now after inserting a new element into an array, now how many elements are there? 11. So what should be your n value? Now the n value gets incremented by 1. So that should be a, so please remember, whenever you do insertion, your n value changes because the size of the array changes. And one more thing, keep it in your mind. In order to insertion, please, you have to have space in the array. Like if I say A of 10, while declaring the array, if I say A of 10 and already 10 elements are there, I cannot insert one more element. Please remember, there has to be some space in the array. For that, please remember, while declaring the array itself, you declare the maximum size, like A of 100. So memory is there for how many elements? 100 elements. So how many elements you keep on inserting? Up to 100 you can insert. Please remember, whenever you do insertion, please check whether there is a space available in the existing array. If there is no space, then you cannot insert. Only the thing is, initially you would have entered 5 elements. If there is a space, you can go on insert an additional element. So after adding an additional element, the number of elements in the array changes. It gets incremented by 1. So this is the algorithm we follow when we do insertion. So let us take one example with the coding, that is using C language. So to how to write a program to insert an element into an array at a given position. So as I already told you in the previous slide, whenever you insert an element into an array, 2 inputs is required. One is the element which you are going to insert, and the second thing is the position where you are going to insert. Okay. So let me take this example. So you have the main function. Then there is an array called as ARR, and it is a static array. Please remember, here we are not talking about dynamic arrays. We are talking with respect to static arrays. Then int ARR of 100. So maximum, and all are initialized to 0. So totally you have a space for how many elements? 100 elements. And initially all the elements are initialized to 0. You can skip this 0 part. Not necessarily that you need to initialize. Just to make sure that there is a space, and wherever there is a 0 means there is the element is not inserted. Just we have initialized all the elements to 0. Then we have declared a variable int I. I is the looping variable. X is the new element or the item which you want to insert. POS means position where you want to insert, and n is equal to 10 is the initial size of the array. So initially, how many elements you are going to store in the array? So that means initially in your array, 10 elements you are going to store. After storing the 10 elements, the new element that will be stored into array. So how to store the initial array? So first you need to create an array of 10 elements. So how do you create? So for I is equal to 0, I less than 10, I plus plus, ARR of I is equal to I plus 1. So what is the elements you are going to store? 1 to 10. The same example I've taken. So in the first element, you are storing 1, 2, 3, 4, 5, 6 up to 10. Okay. Then, so the same example, the coding also I've written. So then once you store 1 to 10, so totally how many elements are there in the array? 10 elements are there. Now, what is the next input you have to give? The new element which you are going to insert. So which is the new element you are going to insert? X is equal to 50. So if you don't want to always insert 50, you can give using scanf statement, printf, enter the new element, scanf, %d, %x. So that's the more efficient way of reading the new item. Okay, but here I've taken x is equal to 50. Then in which position you want to insert? 5. So 5 means, please remember here the position starts from 1. The first element position we call it as 1, 2, 3, 4, 5. but the index value starts from 0. So that means in which index position you want to insert. If the position is 5, means the index position will be always position minus 1. That is 5 minus 1, that is 4. So then increment your n value. Why increment n value? Because now you are going to insert a 11th element. So your n, instead of writing n plus plus here, after inserting you can write here also. Please remember, after doing shifting you can increment your n value, because here I want the position. So here before only we are incrementing the n value. Earlier n was 10, now n becomes 11. So your array size is of how many elements now? 11. So start from, now you have to shift the elements towards the right, starting from the last element. So how do you start? I is equal to n. So I is equal to, in this case it will be 11. I greater than position. So 11 is greater than or equal to 5. Yes. So I told you what is the condition that you have to use. You can shift as long as the elements towards the right of the position is greater than the position value. So what is the condition you are checking? 11 is greater than, so 11 is the last position. So 11 is greater than or equal to 5th position. Yes, it is true. Then come to the body of the loop. Array of I minus 1. What is I now? 11. 11 minus is 10. So array of 10. So what is there in array of 10? 10 is there. Move 10 to array of I. What is I? 11. So you are going to move the element 10 to the next position. Then after moving, decrement your I value. Now I becomes 10. Earlier I was 11. Now I becomes 10. Is 10 greater than or equal to 5? Yes. It comes to body of the loop. Move array of I minus 1. 10 minus 1. Array of 10 minus 1. What is there in array of 10 minus 1? That is array of 9. What is there in array of 9? That is 9 is there. Move 9 to array of 10. So 9 is moved to the which position? 10th position is moved. So like this, keep on repeating till I becomes 5. So once 5 becomes 5 greater than or equal to 5, yes, it is true. Then move array of 5 minus 1. So that is what is there in array of 5 minus 1? That is array of 4. What is there in array of 4? 5 is there. So shift towards the right. So that is the element 5 is moved to the next position. Now in the position 5th, there is a space. Now after shifting, once I becomes 4, is 4 greater than or equal to 5? The condition becomes false. So come out of the loop. Now the space is created for your new element. Then insert. So which is your new element? 50. So that is nothing but x. So x is assigned to array of position minus 1. Why position minus 1? If you are saying in the 5th position in your array, what will be your index position? 5 minus 1, that is 4. So you are going to place 50 in the index position 4. That is a of 4 will be equal to 50. So that is what we are doing. So you are inserting 50 in a of 4. So after inserting, what is that you do? After inserting, so then now you can print the all the elements in an array. So starting from the first position till the last position. So for I is equal to 0, I less than n. Now what is your n value? N value is now 11. Please remember earlier it was 10. Now totally how many elements are there? 11 elements are there. Start printing all the elements starting from the 0 till the 10th position. Sorry, that is the 11th position. Position is different, index value is different. So then come out of the program.
Yes, ma'am.
Okay. So and please try to write your own programs. More and more programs you try to solve. First thing is always remember when you try to solve a given problem, first you should know the logic. Then what constructs you should use. I can implement using for loop, while loop, that is different. But you should know the logic behind solving the problem. Then write in the form of algorithm, then convert to a program. So once you know algorithm, it is easy to convert algorithm into a language by using syntax. Okay. So please remember, first always you should know the logic behind the, solving the problem. So in insertion, what is very important is if it is the last position, what will be your program? So in the previous example, assume I want to insert in the 11th position. So what will be your position? Position is equal to 11, x is equal to 50, n plus plus. For I is equal to 11, 11 greater than or equal to 11. Yes, true. So then come to body of the loop. That means 1 to 10, it will be as it is. No need to shift. Directly go to the last position and insert. So array of 10 will be equal to the array of 5. So no need to shift because the condition becomes false. So no need to enter into this for loop. Okay. So your position is your I. So for example, n is 11 means your position is 11 means. So what will be your 11? 11 greater than or equal to 11. So array of 5 minus 1. Is it necessary to shift? Not required. So directly you place 50 into position minus 1. So 11 minus 1 means, so what will be your 11 minus 1? That is in the 10th position, you will place the element. So that is how you place. No need to shift because you will not enter into for loop. This you will enter into for loop only if the position is somewhere in the middle of the array or somewhere in the random position. If it is at the end of the array, no need to shift the elements. Please remember. Hello. Otherwise, if your position is even in the beginning also, then you have to shift all the elements towards the right, then create a space in the first position, and then you have to insert. So this program will work for all the positions, whether it is the starting position or the ending position or somewhere in the middle of the array. Everything works except if you are inserting an element at the end of the array, you will not enter into for loop because the condition becomes false. Directly you will assign x is equal to array of position minus 1. Otherwise, you will enter into for loop and you keep shifting. So that's how the code works. Now coming to the other operation, the last operation you can do with an array is deletion. Now what is deletion? Deletion means what? You have an existing array. From the existing array, you want to remove an element. Okay. So when I want to remove an element, what do you specify? You need to specify the position from where the element has to be removed. So one is the item and the other one is the position from where the element has to be removed. Now, why position is more enough to remove an element? It is not correct because sometimes you are very specific with an item also and the position. The same items can be like, so for example, the element 2 can be present in an array in 2 positions, but I want to remove one of them. So in that case, what is important is I need to specify the item name also as well as the position. So what is deletion? So deletion is a process of removing an existing element from the array and reorganizing all the elements of an array. Now, after removing an element, you cannot have a space in between. Okay, you need to rearrange the elements. So you need to reorganizing the elements after removing. So that process is called as deletion. Now, so algorithm is delete. Okay, so that you are going to perform and delete operation on an array. So you need to pass 4 arguments or 4 inputs is required. One is the array, the existing array, that is LA. LA is the linear array. LA stands for linear array. N is the number of elements in the array. K is the position from where the element needs to be deleted, and item is the name of the element that has to be deleted. So then the first step is you have to set item equals L of K, because which is the item you are going to remove from the array called LA. In which position you are going to remove? K position. So LA of K is nothing but the item which you are going to remove. So set item equals LA of K. Then you have to repeat for J equals K to N minus 1. That means from the kth position till the last position, you have to move not downwards. Upwards means shifting left. Please remember, in the insertion, we are moving right. In deletion, we have to shift left, because if you remove an element in between, a space will be created in the middle. So now whatever the elements that are there towards the right of that position, you have to shift left side. So that is what we call it as. So from the position where you have deleted till the last element, you have to shift left. So that is what we call it as moving the element upward. So how do you move? So LA of j plus 1 is moved to j. In the earlier case, it was j minus, so j to j plus 1. Here it is j plus 1 element will be moved to jth position. So that is the element on the last position will be moved towards the left. And similarly, that element will be moved towards the left. Till the position where you have deleted, the next element will be moved to the deleted position. So you have to repeat this process as long as the j value ranges from the position where you have deleted till the last element. So the looping should be j equals k to n minus 1. So once the j value becomes less than k, that means all the elements towards the right is being shifted left, then come out of the loop. Then now what happens after deletion? Now the size of the array is being reduced by 1. So your n value should get decremented by 1. Insertion will increment your n value and deletion will decrement the n value by 1. So after shifting towards the left, then you have to decrement your n value by 1. So set n equals n minus 1 and come out of the program. So that says, I'm going to say deletion is done. Coming to the program with respect to deletion. So the same example I've taken, like what I've taken for insertion. Now no need to give a new element because the existing elements needs to be deleted. So let us take this example. Assume you have an array called A. A is equal to 1, 3, 5, 7, 8. So your array size is 5. So your existing array size is 5. So that is n is equal to 5. And what are the elements that is stored in the array? 1. So the first element is 1. Second element is 3. The third element is 5. The fourth element is 7. And the fifth element is 8. So totally you have 5 elements. Now k gives you the position from where the element has to be removed. So the k is equal to 3 means you are going to remove the third position element. Position means not the index position. If k is equal to 3 means what will be your index position? 2. So please remember, position will be always 1 greater than your index position, or index position will be always 1 less than your position. So if k is equal to 3 means it is the third position in the array, and with respect to index it is 2. Okay, 3 minus 1 gives you 2. So which is the element we are going to remove? 5. So 1, 3, 5, 7, 8 is there. No. So which is the element that is present in the third position? That is the element 5. So we have to remove the element 5 from the existing array. So then printf the original array of the elements are, for I equal to the original array elements are 1, 3, 5, 7, 8. So that will be your first output. Now initialize your position from where you want to delete to j. So what is your k value? Third 3. So 3 is assigned to j. So that is, it tells you the element you are going to delete is from the third position. So you have to shift all the elements from the third position onwards till the last position towards left. So check whether j is less than n, because the position from where you are deleting should not be your last element. If at all, if your position is in between your array, that definitely your j value will be less than n. What is your n? 5. And what is your j value? It is 3. So 3 is less than the 5. That means after the third position, there are some more elements to that which are left. Then 5, as the condition is true, come to the body of the loop. A of 3 is assigned to a of 3 minus 1. So what is a of 3 minus 1? 2. So that is, so the third element will be shifted to the left. So while shifting, you need not go to the last element. Please remember, while shifting left, so which is the element that you will shift immediately? 7 should be shifted to the third position. You no need to go to the last position. Shifting left means 7 should be shifted first and then 8 should be shifted first. So because it is left side. So a of j, what is there in a of j? That is 7. 7 is shifted to j minus 1. 3 minus 1 is 2. So that is 7 will be placed in the third position. Then again j gets incremented. J becomes 4. 4 is less than 5, yes. If j in A of j, 8. 8 is moved to the next left position. A of 4 is moved to A of 3. That is 8 is moved to 7th position. So then j becomes, so j gets incremented, j becomes 5. 5 is less than 5, the condition becomes false because all the elements towards the end is shifted left. So you have shifted 7 to left, you have shifted 8 to left. So that means all the elements are shifted left. Now you will come out of the loop. That means now the existing elements will be 1, 3, 7, 8. Okay. So automatically the number of elements will gets decremented by 1. So after coming out of the loop, your n value should be decremented by 1. Earlier n was 5. After deleting the element 5, now the n value becomes 4. So that is n equals 5 minus 1, that is 4. Then now print the new array elements. So printf I equals 0, I less than 4, I plus plus, print a of I. So it will print 1, 3, 7, 8. So this is how deletion works.